Well, hello again. Gonna try this again. First attempt failed due to dodgy sound settings and meowling cats. Let's give this another go. It's been so long since my last video. I've added so many things up. I'm probably not even going to remember them all now. Let's start with the lighting. You may notice that it's a bit brighter indoors. That is because I finally figured out how, using the new lumen system, to get light to bounce more effectively around. So the light comes in the window, leaves that patch on the floor, which is then reflected, and that propagates light around the scene a lot more effectively. You can see on the other side of the house, because the sun is on this side, so on this side of the house you're not going to get the same effect. But if I had to move the sun to this side, let's see if we can do that. There we go. You will see the same effect, which I think is pretty cool, given that time is going to advance. I think the last video I made was my time lapse of me building the house. The video before that, I think we were talking about how completing chores will advance time. Well, I've got more to show you there as well. Let's just get the sun set back to where it's supposed to be. Okay, yeah, the next thing I wanted to show off is this. One of my gameplay ideas is to have the player be startled by what we can only assume is the cat, and in order to do that I need to be able to trigger the cat flap. So I have bound it to a key for now, so you can see that. So I imagine I'll have a trigger box somewhere on the floor. The player walk in, you'll hear a cat yowl in the left speaker, which will turn your head left, and as you do you will see that, which I think is pretty cool. There's going to be a lot of that sort of thing in this game. Still building systems at the moment though, so we'll see. Okay, what's next? Yes, one of my favorite features. Let's go in here and switch a light on. I have in the past mentioned the idea that there might be some sort of psychedelic experience tied into what's going on in the house, and finally got a way to make that happen. Let's just turn this up a little bit and you'll notice things are starting to look trippy. So I've got it at the moment. I can scale it up 10 notches, which I think is quite an interesting effect. And all I'm really doing is, well, firstly I'm adding some bloom to the lighting so light sources look more exaggerated. And let's just switch this off again. And then the other effect is, if we go into the code here in the player blueprint, which is not allowing me to move it, there we go. You'll see I'm using the post-process volume of the first-person camera as opposed to the post-process volume. Jesus, that's a hard sentence to say. As opposed to the post-process volume that's actually embedded in the map, where I'm controlling things like exposure and contrast, etc., and saturation, all that sort of thing. So instead of using that, we're using the post-process volume attached to the camera so that it doesn't affect any of my other settings. So at begin play, we just tell the post-process volume that the blend weight of the effect that I've added is 0. There you can see it there. And then we have a little variable here called is hallucinating. Now the reason I've got that there is because this is all running on event tick, and event tick basically runs code every single frame, so it's not very efficient. So I've got this variable here called is hallucinating, and all I need to do is switch it off. And now when we play the game again, those buttons to enable trip mode don't do anything. And yeah, obviously this is not going to be triggered in the final game by button presses anyway. This is just for testing purposes. But also I don't want this code all running in the background whether the player is hallucinating or not. But still testing it all out, so we'll leave that on for now. And to get the effect, all I'm doing is animating the chromatic aberration. Now, if you've never heard this term, it's actually a photographic term. It's to do with the way that light is split into its constituent colors, red, green, and blue, at the corners of lenses. And the more expensive the lens, the less chromatic aberration you get, but all cameras have it to some, all lenses have it to some extent. And I'm basically just using this effect and animating it with a timeline node to get that trippy effect. So we're splitting light at the corners of the camera lens into 3 colors and then putting them back again. That gives it that breathing kind of look, which I quite like. Yeah, so that is the trippy effect. Like I said, there are a couple of other things going on. This is just the code to handle the button presses to test it out. There are a couple of other things going on, but nothing too serious. Okay, I've got a list here. Trip mode, cat flap animation, power trip. Okay, now this is interesting. I can't remember if I showed this off in a previous video or not. But basically, I want a way to be able to turn off the power for the entire house, or for the entire property really, at once. So let's go and switch a couple of lights on. Yeah, that should do it. Let's put the kitchen and the pantry lights on as well. Stand where we can see them all. Now, if I trigger the button, now I don't know if you heard that there's a faint thud. If you can hear that. If I go and stand on this side of the house, you'll hear it more clearly. Here we go. I'm going to trigger the power failure, and I'm going to switch it back on. Now that thud and that click is the breaker switch. Now obviously, again, for testing purposes, I've got a key bound to power, but if the power goes out in the game, you're going to have to go down into the dark and scary basement all by yourself with a flashlight if you're lucky, and find the breaker box. And that's what that noise is. Now the cool thing about the noise is I've yet to make a video about how sound works, and I'm waiting on that because I'm planning on doing a lot of sound design myself. But very briefly, I found a way in the code that handles the way that the sound works to do a high frequency cutoff on objects that are no longer in sight. So because of the way that sound travels, in other words, the further away you are from a sound source, the bassier it will seem, because the sound waves that make up bass frequencies are longer, therefore travel further. Which is the way that sound propagates. And the game, amazingly enough, has provision for this. So you can roll off the top end of a sound the further away you get. Now, I wanted there to be an audible click from somewhere in the house when the power goes out. Just as like a kind of feedback thing. And you may have noticed there that there's a delay. You can probably hear my key presses. And you'll notice there's a delay here. And the reason for the delay is I had to do all kinds of timing tricks to make this work. So if I flip the power, the switch goes off immediately. And if I flip it back on, there's a kind of slow tug pull thing that happens there. Okay, that's the power system. The way that it works is we have in our player blueprint an event dispatcher. I think I was speaking about event dispatchers in an earlier video, saying I couldn't remember. I went through my notes and I couldn't figure out how it worked. Actually, I went and watched the video. It's actually really simple. You can see I've got several set up here now. I have one for the mains power, one for the cat flap, and one for the sprinkler, which we'll get to. All the mains power event dispatcher does is I can show you here in a lighting blueprint. This is going to run on event begin play, which means the stuff has got to be there as per my explanation in a previous video. And then all we do is we bind this event over here to the event dispatcher. And then when this event dispatcher is called from inside the player blueprint, which I think it is done up here, I've just got a custom event here and that calls this. And the way that it works is I think the power box does it, yeah. So in the power box blueprint, when the power goes off, we just call this event in the player blueprint, which then calls this event dispatcher, which then calls this event dispatcher in every single lighting blueprint. Now, as you can imagine, I had to go and add this code to every single lighting blueprint, and every single lighting blueprint is different because every room in the house has a different number of lights in it. So you can imagine how much fun that was. But it's done now and it's all working, and I'm very happy about that. That was a fairly complicated thing for me to work out. Okay, and the last thing I have to show off is this. I decided that I thought a greenhouse would be cool. And I also decided that I wanted the pieces to be modular so that I could build the pieces myself and then assemble the greenhouse in any kind of shape or configuration that I wanted. This was 2 days of almost literally pulling my hair out and going and reading Pythagorean theorems and trying to figure out what angles to make the stuff. I must thank my most excellent friend Moody here for an entire afternoon of trial and error. But yeah, so you'll see here we have a corner piece and a roof corner piece, and then these slanted pieces, and then those slanted pieces, and then the door. And they all, let me just undo that before something terrible happens, and they all slot together perfectly. Made the glass material myself as well. I did need to use a tutorial for that, and it's probably one of my more complicated materials as of now. You can see this is what the code looks like. I'm not even going to try and explain this because I barely understand it myself. Like I said, I followed a tutorial and it makes sense, and I did make some changes. Like in the tutorial, the guy made his own normal map and I used one that I found on the internet for frosted glass, and then just used a texture coordinate node to set the size of the normal map. I can actually show you that. If I open a material instance of my glass and do this, if I scroll down here, if I set the normal map tiling to 1, you'll see suddenly that's frosted glass as opposed to slightly wavy distorted glass. So yeah, that was the greenhouse pieces themselves. And then on the inside I needed a sprinkler system. Again, this is still very much a work in progress. So the door sound is not going to be the same door sound as everything else in the game. It just is at the moment. And I'm still busy putting plants in pots, as you can see. The sprinkler system is this whole massive copper tubing here. This I also completely and utterly designed by myself. Here's the tap that turns the sprinkler system on, and you'll see the little sprinkler heads come on and a pleasing mist forms as the plants are being watered. And I haven't done sounds yet, and I'm not 100% happy with the water particles, but again, work in progress. And then the way this works is, this is going to be one of the chores that the player needs to complete, but I don't want the player to have to come back and switch the sprinklers off again. So in the game's instructions, the player will just be told, turn the sprinklers on, and the timer will switch it off after a certain amount of time. So how do we time that? Well, I figured the easiest thing to do would just to have the player complete another chore and then have the sprinkler system switch off on its own. And this proved to be trickier than I thought it would be, but I did get it done eventually. So you'll see here, I dragged this plant in now because watering this plant counts as a separate chore. So you'll see what happens. We'll turn the sprinkler on, give it a second. And then when you're somewhere else in the property and you perform another chore, like watering this plant, you'll see the sprinkler system switch off. This is the code for the sprinkler system, and you can see there are 16 copies of the particle system. Oh yeah, I should mention that as well. I designed the particle system myself. It's my first foray into Niagara, which is Unreal Engine's built-in particle management system. You can't really see how it looks here in the preview window, but you could see how it looked in the viewport, and I'll get into this stuff another time when I know a little bit more about what I'm doing, but this is what the particle system looks like. Then, if you open the player blueprint, I believe this is where I did the code. Yeah. So what happens is the game checks to see if the sprinkler is on, and then we cast to game mode and we get the number of chores that have been done so far. Then we check it against the number of chores that had been done when the sprinkler was first switched on, which I believe is code that runs here, yes. So you can see here, sprinkler on, and here we get the chore counter and we set number of chores when sprinkler activated to be the same as the chore counter, and then we set sprinkler to on. So when the game checks to see if the sprinkler is on, we already know that these variables have been set correctly, which means they will be equal at this point. As soon as they are no longer equal, in other words, as soon as the chore counter has gone up by 1, we call the sprinkler event dispatcher, and that switches the sprinkler off. I can delete the sprint string here, that was just for testing purposes. Anyway, that's all for this video. Thanks for watching. Don't forget to like and subscribe.